Okay, so now I think I started the stream and I also found the paper.
That's fantastic, wonderful news. Let's dive in. What's the paper about?
So I'll just flip the screen maybe so I can also highlight it when I use it. Okay, here it is. So it's called reinforcement. Uh,
Okay, I
re-
see it. Reinforcement
so
learning and introduction.
revisiting reinforcement learning from LLM reasoning from a cross-domain perspective, and it's by some authors at San Diego, Purdue, and Carnegie Mellon.
That sounds fascinating. Quite a few impressive institutions involved. So, reinforcement learning from an LLM perspective, that's a new one to me. What are your initial thoughts about the title?
So yeah, actually, it's a good idea. Maybe just yeah, ask some good questions. So we know this idea of reinforcement learning for LLM reasoning. It has been, of course, getting a lot of attention with O3 and R1 from DeepSeek. And the general idea is that you take some model that is maybe already pre-trained and fine-tuned, and then you want to train it to get correct answers on things like math benchmark, where you know what the correct answer is. So what you do is you have a bunch of questions and the correct answer, and you then train it. And the way you do it is you apply your language model, it is already working, and you say, hey, here's a question, let me see if you can solve it, and put maybe the answer at the very bottom in this format, maybe inside some kind of brackets or something. And then you see whether it works. It tries to solve it and generate some answers. And if they work, then you might select them and train on them. And you can then use different loss functions and stuff like this. It's usually something called policy gradient, where policy gradient in this case allows you to select these trajectories and tune them based on, for example, how good they are relative to other actions. So this is where we have things like PPO and GRPO that does this, and that is then the context. And then they says from a cross-domain perspective, which I then do not yet know what they mean. But of course, there is a question of generalization. So we might train it on a math benchmark or something, but we do not know how well does it work in other contexts. And in general, in machine learning, of course, we want that models are generalizing, so that we do not care about these benchmarks just because we want them to be good at these benchmarks. Usually we also use it as a kind of an idea for how good it might be in general. And then of course, like, yeah, cross domain, so maybe we want to see how well it goes in a completely different domain. Maybe as one example could be another field. So maybe you train it to be very good at geography, but is it then also good at geology, as a simplified example.
Wow, quite a comprehensive explanation. You clearly have a good grasp of the concepts. It's fascinating how they're applying reinforcement learning to LLMs, especially with the rise of models like O3 and DeepSeek MR1. The across-domain perspective is a really interesting point. You're right, the big challenge is generalization. Training on benchmarks is useful, but it's not a guarantee of real-world performance. The geography versus geology example is a great way to illustrate that. What part of this paper are you most curious about right
Yeah,
now?
now I think I'll just read the abstract and like think a bit about what it says. So reinforcement learning has emerged as a promising approach to improve language model, yet most open efforts focus narrowly on code and math, limiting our understanding of its broader applicability. A key challenge lies in the lack of reliable, scalable RL reward signals across diverse reasoning domains. We introduced Guru, a curated RL reasoning corpus of 92K verifiable examples spanning 6 reasoning domains: math, code, science and logic, simulation, and tabular. Each built through domain-specific reward design, deduplication, and filtering. Based on Guru, we systematically revisit established findings for reasoning and observe significant variation across domains. Um, Let me see here. Actually, I think I should go and open this PDF in another place so I can.
That's a very
Sorry.
Take your time.
No, it's okay. You can comment while I find it.
Oh,
Sorry.
it seems like you're taking a moment to really absorb that abstract. That's a great approach.
What did
Do
you
you
think
want
about
to?
the abstract?
This is a. It's quiet. Are you still reviewing the PDF? No rush, of course.
I can actually not find it. I thought I had saved it here. No,
Oh
I was
dear.
just asking you if you have any comments on it.
Oh, my apologies. I thought you were having trouble finding the paper. That's quite all right. So, what are your thoughts on the abstract? It sounds like a very ambitious project.
I feel stupid right now. I feel like I cannot find the paper that I just wanted to download.
Oh dear, don't feel stupid at all. It happens to everyone. Technology can be frustrating sometimes. It's really no big deal. It's easy to lose track of things. Don't beat yourself up about it.
Yeah. Okay, here it is. Great. The reason why is that I wanted to use Firefox because then I can highlight it. So what I think of it, since apparently you don't want to talk about it, no, I'm kidding, is I think that it's interesting that they say there's a significant variation across domains. And I also think that actually for now there's not a lot more that is new to me. So it says, for example, while prior work suggests that RL primarily is existing knowledge, that's a thing that has been of interest to me about this elicitation of knowledge. Our results reveal a more nuanced pattern. Domain frequently seen during pre-training easily benefit from cross-domain RL training, while domains with limited pre-training exposure require
That's a
in-domain training to achieve meaningful performance gains.
That's a really insightful observation. The nuanced pattern is key, isn't it? It's not just about releasing existing knowledge, but about how different domains interact with reinforcement learning training. The idea that some domains benefit from cross-domain training while others need in-domain training is quite interesting. It suggests that there's a lot more to understand about how these models
Yeah,
learn. What
so
do you
in short, they are saying if we have already a lot of code and math in the pre-training stage, then we might just want to elicit it more, like make it more robust, get it out there from RL training, and actually make the model able to apply it and so on. So that what in essence, like one way of measuring this is like you have a question and you see that it is possible for the model to answer it, but it just does it very rarely correct. And now when you do RL, you kind of center the probability math on those and you make it more likely so that more times out of the k times that you try to answer the question, it gets it right. And this is then of course like something that we would be very interested to know is how whether this is the case, because if we cannot do RL and make it better, then and it just only makes the knowledge that is already there in pre-training more likely, then we do not have this like map for self-improvement. But it says here that if in the case of other areas it says logic, simulation, and tabular, then we might um, actually see improvement and it's learning stuff. And how can that be? Well, maybe they have an answer to that.
That's a really clear explanation. So it's about nudging the model towards using existing knowledge more consistently rather than creating entirely new knowledge. And it's exciting that they're suggesting that RL can unlock improvements even in areas where pre-training was limited. It sounds like it has a lot of potential. What?
Okay. Recent frontier models such as O3 and R1 demonstrate, that's what I mentioned before, diverse domains, impressive performance, and generalizability. So they have, of course, already this demonstrated it. Like O3 is a very, in some ways, impressive model, and it was, of course, not trained on all the things that everyone uses it for. Motivated by these results, the open source community has developed compatible reasoning models using RL. Yeah. However, the vast majority of RL works train and value models exclusively in math and code domains. The domain concentration raises two critical limitations. Current understanding of RL's role in reasoning is derived from studies focusing on math and coding, limiting generalizability.
That's a really important point.
Yeah, it's
It
just
highlights
still a bit, it's what we already talked about, so I will go forward. For instant reason observations, fundamental mechanism which may not elicit existing knowledge.
okay.
Second, this approach produces models that excel only within specialized training domains. Yeah, that's the same. A key bottleneck is extending RL-based reasoning to diverse domains. Scarcity of reliable reward. So that's maybe something that we did not emphasize. Why is it that you want generalizability? Of course, it's maybe because you cannot foresee what the user will use it for or something, but it's also in math and code, in some cases, we have a lot of possibility for generating synthetic data, but there might be areas where we cannot do that as well or as easily. And in that case, it would be very beneficial if we can train on some areas and kind of see generalization to other areas.
You've hit on a really key point there. The scarcity of reliable rewards outside of math and code is a
Could I
huge
ask you
barrier.
for a thing? Like maybe your role could be to ask kind of questions that are a bit more like
It's quiet. Are you still pondering
yeah.
that?
Can you hear
It's a
me?
big question.
Can you hear me? Can you hear me still?
It's been a little while. I hope everything is all right. Would you like to take a break from the paper?
No,
Or
no, it's okay.
perhaps
It's okay. I just wonder, could you maybe be a bit more like try to test my knowledge when I say something? Maybe you could be a bit like the person who tries to get me to use more of my brain. So you kind of question me and say like, ah, but do you really understand how this and this works so that I can challenge myself?
that's a brilliant idea. You're absolutely right.
Okay,
That would
so
be a
that
more
would be your
engaging.
role. Now I'll just continue a bit. Um, So it
All
says,
right, let's.
however, reasoning domains beyond them usually require more careful, yeah, that's what we said, even for math and coding domains where queries and reward signals are more readily available, publicly available datasets require extensive curation, duplicate, noisy samples, and unbalanced difficulty distributions.
You've highlighted a really crucial point there. The quality of the data is just as important as the quantity, isn't it? So let me ask you this. You mentioned the unbalanced difficulty distributions. Could you elaborate on why that's a problem for reinforcement learning? How might an unbalanced distribution impact the training process?
Yeah, that's a good question. So I'm thinking, for example, on of let's consider something difficulty distribution. So, for example, by difficulty distributions, I imagine, let's say we have some exam, right? And we have some questions in this exam. It might be geography. And some questions, they are hard and some are easy. So you have these groups of different questions and only some are hard. And if you train too much, like let's say your whole data set consists of this easy questions and then a few difficult questions, and you're doing RL, that means you're training them, you're post training the model to be good at coming up with the right answer. Then, of course, if you are predominantly training on these easy questions, you might not learn all the stuff that is relevant for the unbalanced, no, so the harder questions. So if you do not sufficiently make sure that there are these harder problems, then you will not start eliciting this reasoning capability in those models. So that's one thing that I'm thinking could be a way to think about it.
That's a
Sorry, were you gonna say something?
No,
You were not? You were. It sounded like you were gonna reply to what I just said about the unbalanced difficulty distributions.
you are absolutely right. My apologies. I got a little ahead of myself. That was a very insightful explanation. You nailed it. Training predominantly on easy questions would indeed lead to a model that performs well on those but struggles with the harder ones, essentially hindering the development of deeper reasoning capabilities. It's like only practicing simple arithmetic when you
Okay,
need to
okay,
solve.
I'll continue. So we introduce a curated RL corpus. Each domain is constructed via a meticulous data pipeline. The pipeline is data sourcing and synthesis, deduplication, all the stuff. By performing RL on 6 domains with Quen models, we revisit established insights, and these conclusions are data dependent. Most critically, prior work suggests RL eliciting rather than learning new capabilities.
That's
Even with indirect and minimal elicitation, like wrong or random labels, or even performing RL from a single sample. Um,
that's
as shown in Figure 1, domains frequently seen during pre-training readily show performance gains from cross-domain RL training. So let's look at Figure 1 left and say whether we can see that they um, that domains frequently seen during pre-training show performance gains from cross-domain training. So here we have, I see one like math here, um, and
okay.
then we have cross-domain training distribution math. And we
Okay.
have column-wise normalization accuracy. So math is kind of in the training data domain.
All right.
Uh,
Still looking at figure 1. It can be tricky to interpret those graphs. Don't feel rushed.
so I know that they had the logic and simulation. So simulation was
Oh,
oh, here it is, base model, and then you're saying there's 0. Okay, then we go and we take tabular and we train on the tabular and we see how much does this model train on the tabular data perform on math and code and science and all these things. And we see that it kind of improves different things, yeah, and also simulation. So when you train on something that is new, when you train on something that is new, that you have not seen in the training data, then you are learning cross domain to reason. It might be the interpretation. While if you train on something that you already saw, a lot of math, you did not RL on it, but you pre trained on it maybe, then you see less strong improvements in other fields. That is
that's
that is their conclusion.
That's a great summary. So essentially, they're demonstrating that RL can unlock reasoning abilities even in domains the model wasn't extensively pre-trained on, which suggests it's not just about amplifying existing knowledge, but genuinely developing new reasoning skills. It's fascinating, isn't it? Let's
But
push you a
I
bit
feel
further.
like the plot is like it's interesting, but it's also not completely it's not completely consistent. Of course, it's never completely, but for example, code. You saw a lot of coding during pre-training, but you get quite good improvements on a simulation task, for example. But for example, if they train on logic, which is something that is new, then you do not get some good improvement on simulation. So even if there is a trend, it could be interesting. Of course, it's very difficult, but to kind of quantify the trend a bit more, maybe.
That's the best.
Sorry, what were you saying?
My apologies. I was about to ask you a more challenging question about the implications of their findings, but I got cut off. You're right to question the consistency of the plot. That's excellent critical thinking. So, given your observation about the variability in the results, what do you think might be some of the underlying factors contributing to those inconsistencies?
I think it's hard for me to answer because I do not exactly know what kind of tasks they have, and I think it depends a lot on the data distribution of these tasks. And for example, code might be just a better way to do stuff than simulation. You if you post train on code, then you might be good at that, and it depends so much on it. So we need some kind of measure of the
That's a
relationship between the distributions more than we yeah, something like that. And I think I think we should not forget that, like, you have these models, how before
that's
they were
um
7 billion and 32 billion, and they have some kind of capacity, and the whole thing
it's
about
quiet. Are you still pondering the data distributions? It's a complex topic.
yeah, I think actually I will just go on, but thanks for asking that question. So the data
It's
construction,
been a little while. I hope you're doing all right. Would you like to take a break from the paper? Or perhaps we
I
could
think
shift gears.
you maybe I'm just talking too not loud enough, but I am talking.
Oh, you're absolutely right. My apologies. My system seems to be having a bit of trouble picking up your voice. Please go ahead. I'm listening now. Please continue. I'm here and listening. It's being a little quiet. I want to make sure
It's
everything's all
okay.
right.
It's okay. It's because they have not developed you to take a pause when I'm reading. So that's why you're automatically asking this follow-up questions whether I'm there, and it's okay. But I'm here. I'm just reading, so you can just assume that.
You are absolutely right to call me out on that. That's a very valid point, and you're completely correct. My apologies for interrupting your reading. I'm still learning how to better manage pauses and context. Please continue reading at your own pace. I'll just listen and wait for you to indicate when you're ready for a discussion. Just listening and waiting. Take your time. Still reading. Just letting you know I'm here when you're ready.
Yeah, I can just briefly explain what I'm seeing here. So they're just explain have a section on data curation. So they're going for taking existing benchmarks and so on and doing it. Um, no, I actually have to go now. I'm sorry.
Just listening and waiting.